A lot of people immediately think about Docker whenever you mention the word containers, but there are a lot of other container technologies out there. First, we have LXC, which is actually a well-known set of tools, templates, library, and language bindings for Linux containers. It is very low level, very flexible, and covers just about every container feature supported by the upstream kernel. Now, Docker is really an extension of LXC's capability. This is actually done using a high-level API that actually provides a lightweight virtualization solution to run different processes in isolation. Now, Docker is actually developed in the Go language and utilizes LXC, cgroups, and the Linux kernel itself. Another popular container technology or package is Rocket. And you can get information about Rocket and the source code at the GitHub repository that I'm actually including here. Now, another container package is called OpenVZ, and it's not as popular as Docker or Rocket, but it is actually making its round nowadays, right? I'm actually sharing the website where you can get the code and more information about OpenVZ. I have been mentioning the word container many times here, but you may actually ask, what is a container, right? So a container is an image or a lightweight standalone executable package of a piece of software that actually includes everything that you need to run within that quote unquote container, right? It actually has its own code, runtime, system tools, system libraries, and its own settings. Now, containers isolate software from its surrounding, and it actually helps reduce conflicts between the teams, so the different development teams running different software on the same infrastructures. You also may ask, so what is the difference between a container and a virtual machine? Virtual machines generally include the whole operating system along with the application. And they also need a hypervisor, to actually run and control the VM. VMs also tend to be very big in size since they include the whole operating system, like I mentioned before. And also because of this, they also take up several minutes to boot up the operating system and initialize the applications that they're hosting. Now, containers are way smaller and perform much better and can start almost instantly. Now, the biggest advantage in favor of container technology is that they can be created at a much faster pace than VMs, right? Than virtual machines. Their lightweight footprint enables less overhead in terms of performance and size. Now, containers increase developer productivity by removing cross-service dependencies and conflicts. Each container can actually be seen as a different microservice, and you can upgrade them independently very easily, right? So that's actually one of the biggest benefits from actually running, a microservice architecture or a multi-container architecture, right? So that's actually because each image of a container can actually be version controlled, so you can track different versions of the container and again, upgrade them very easily. Now, containers encapsulate all the relevant details like application dependencies and also the operating systems. This actually makes them super portable across many different systems. Now, most containers are based on open standards and can run on all major Linux distributions and even Windows. Now, going back to Docker, right? Docker is supported pretty much in all major cloud providers like Amazon Web Services, Google Cloud Platform, Azure, and many others, right? Docker can also be integrated with tools like Ansible, Chef, Puppet, Jenkins, Kubernetes, OpenStack, Vagrant, and dozens of other tools and infrastructures. Of course, this is not a course about containers and Docker, right? However, if you have never played with containers, I recommend for you to do two things. Download Ubuntu or any other versions of Linux, and then put it in a VM. Then install Docker, right? As I'm actually showing here. This is actually a brand new installation of Ubuntu, so you can actually simply install Docker with an apt-get install docker.io. And yep, that's actually pretty much it. Right? That command will actually install Docker, and then In there, you can actually, of course, install your own Docker containers. Can download a few. As a matter of fact, we will be covering on how to build your own lab later in this course, and you will learn about different vulnerable web applications that you can actually use to practice your skills. And I'm gonna show you how to install, those applications, and especially, things like WebGoat and DVWA in a Docker container, right? So that will actually get you familiar with Docker operations. What are Docker files, what is Docker Compose, and also how to expose and bind ports from the Docker container to the main operating system. Now, I also have a list of Docker-related references in our GitHub repository, and I'm going to be mentioning this GitHub repository throughout the course because it's actually one of the best resources that you probably can actually get out there. We probably have about 5,000 resources related to security, penetration testing, incident response, and many others. And there I also have a link of the one of the most comprehensive container-related reference list that I actually have found online. So feel free to use these resources to gain a better understanding of these technologies and, of course, of the container and micro architecture or micro service architectures as well.